Good morning, everyone. Welcome to our third workshop on measurement of sulfur dioxide through Vinmetrica method. So today you're going to learn about how to measure sulfur dioxide using that method, but you're going to learn about how to manage those measurements, how to manage the use of sulfur dioxide. So we decided to offer that online virtual live workshop to make it easier for all of you to participate and to learn different knowledge and skills that you might be able to use in your own space and winery. So today I'm going to be behind the screen, but Alexander Gapinski is going to be the presenter today. He's a research assistant in my lab, and he's a former master student in my lab as well. So I'm going to leave you in the hands of Alex.
Hello, everyone. As Dr. Waterlow mentioned, my name is Alex Gapinski, and I am a research assistant in her lab. I've been working on putting this workshop series together for everyone on wine chemistry measurements. And today, we are going to focus on measuring SO2 or sulfur dioxide content by the Vinmetrica methods. Just to lay out some learning objectives for the day, we're going to go through and list some roles of sulfur dioxide in wine, explain how pH affects forms of free SO2 and how to modify additions accordingly. And then we'll understand the risks associated with inappropriate management of SO2. And we're going to actually use the Vinmetrica equipment, or I'm going to demonstrate the use of Vinmetrica equipment to measure free and total SO2. And from those measurements, we'll do some calculations. And we'll be able to calculate the appropriate amount of KMBS, or potassium metabisulfite, to add for a targeted level of free SO2. And then we'll also recognize proper waste management procedures. So to start us out, what exactly is sulfur dioxide? So it is a molecule with one sulfur atom and two oxygens. You can see the structure at the bottom. And it's one of the most, if not the most important additive used in food and wine production. It's used as a preservative, and it's been used since Roman times, and it can be added at different points throughout the winemaking process. Usually it's added as a liquefied gas or a sulfite salt, and it's very soluble in water with different species at equilibrium in the system. So sulfur dioxide, or SO2, is often perceived by consumers as having a negative health effect, with the most severe reactions occurring in like 3 to 10% of acute asthmatic population. So it does have some negative health effects, but its value as a preservative still makes it widely used throughout the industry. So as I mentioned, sulfur dioxide is a preservative, and it has two main actions. The first is antimicrobial, so it can kill some bacteria and inhibit yeast growth. And typically, we recommend different levels of SO2 depending on the wine style. So for dry red wines, we'll target a 0.6 milligram per liter, or ppm, those two units are equivalent, of molecular SO2 for antimicrobial protection, but we'll up that to 0.8 ppm for white wines, and even a little bit higher if your wine has residual sugar. And that's because if you have residual sugar, that's what microbes like to feed on, so you'll want a little bit more protection in those wines. In addition, it acts as an antioxidant, inhibiting the action of dissolved oxygen and the action of enzymes like lactase, which occurs in botrytized wines, and also polyphenol oxidase, which is naturally occurrent in all plant tissues. There, we're typically recommending 30 ppm, or milligram per liter, of free SO2 for when you're packaging and glass packaging. So the type of wine affects the amount of sulfur that you'll need, as well as the type of packaging. So you'll notice that I discussed different forms. So the molecular SO2 for the antimicrobial activity, and free SO2 for antioxidant activity. So that leads us into discussing those different forms that I mentioned that are in equilibrium. So sulfur dioxide as a molecule will dissociate when you mix it into water. And you can see those different species in the red box there, different forms. The molecular SO2 will shift over to the bisulfite form in the blue writing there. And then also there's a sulfite form. in green. And the graph there on the left shows us along a pH at the bottom, the x-axis, which form of free SO2 dominates depending on the pH. So from 0 to 100%, we move from, if we're at really, really low pH, 0 pH, we're out at about 100% of the molecular SO2. But then as we cross into the wine pH, which is highlighted by the blue band from pH 3 to pH 4, we have much lower content of the molecular SO2 with higher bisulfite form, the blue. And so that's where we're playing with the balance of the pH of the wine and the different forms of free SO2 to get the antimicrobial and antioxidant protection that we need. In addition to pH, those forms of SO2 will be modified slightly depending on alcohol content and temperature, but pH is the main factor. So in addition to the free SO2, we also have bound SO2. So a certain portion of the bisulfite form of free SO2 can bind to different wine components such as sugars and anthocyanins or acetaldehyde, which is an oxidation product of ethanol. So when we add sulfur dioxide for protection, a part of that will bind to those components, and so we end up needing to actually add more to have adequate protection for our wine. And then the combination of the free and bound SO2 together equal total SO2, which is actually what's under legal requirement. When we go and look at what the laws say in the US, wines have a legal limit of SO2 content of 350 ppm. So that's the absolute maximum. It's a little bit lower in the European Union and can vary depending on wine style, but in the US, it's 350. That being said, you can still have too much SO2 in terms of over the sensory threshold, even being under that legal limit. So it's important to have proper management of SO2 additions to make sure you're not going over that sensory threshold, which can come off as a sharp odor or sort of a burning match. Sometimes it can be swirled out if it's not too high, but otherwise it can be almost considered a fault and wine would be unsaleable. So now that we know a little bit about what SO2 is and why we use it, we need to know how we can measure it. How do we monitor the level of SO2 in our wines? So one of the first methods developed dating back to 1892 is known as the Ripper method, which measures the sulfite content by titrating it with iodine to a blue endpoint. So iodine and starch, which is added into the solution, turn blue with the sulfite present. Based on that method is the Vinmetrica method, which is the method we're going to be demonstrating today. And that detects, again, the level of free iodine after the SO2 has reacted. So we're using an electrode. We've got that picture on the top left there, a little blue electrode, which we put in our wine sample as we're adding the iodine titrant, and then that reacts with the SO2 present. Another method, which we'll cover in a different workshop, is the aeration oxidation. And that's where we acidify wine to shift all of the free SO2 to molecular form, which is volatile. And so that will leave the wine through a stream of gas, air, and be converted to sulfuric acid, which we can then titrate with a base, sodium hydroxide, and measure how much SO2 was in the wine indirectly. The last method is a headspace gas detection tube, which is based on Henry's law coefficients on partial pressures of gases. So as I just mentioned, the SO2, the molecular SO2 form is volatile. So you can kind of see in the picture at the bottom right, we have a syringe filled with some wine sample, and then there's headspace above that. So just air filled in there. So after a certain amount of time, the amount of SO2 in the wine and the headspace will equilibrate, and then we plunge the syringe and we get a color change in the little tube there. So you can kind of see it's yellow and blue. We've tried to do this method in the past, but we've had kind of inconsistent results. So still a little bit more work to go on this method, even though it is kind of quick and cheap to use. So before I get into the lab demo, I just want to touch on some lab safety and best practices when thinking about measuring SO2. So First thing to think about, you'll notice I'm wearing a lab coat. If you're working in your winery or something like that, you might have a designated shirt, flannel, you might even have a lab coat, but making sure that you are protected or your staff are protected when they're working with chemicals and irritating substances like acidic wine and sulfur dioxide, which is respiratory irritant. So things like gloves, goggles, closed-toed shoes, all the good protection that you need. Another consideration is to use distilled or deionized water to rinse and calibrate your instruments, and this helps to avoid mineral buildup. You'll notice if you just leave a cup of tap water out to completely evaporate, you might have a little bit of residue in there. And if you're using the distilled or deionized water, those things are removed, and so you have a cleaner, purer water to work with that will avoid that mineral buildup. So one of the pieces of equipment that we use when measuring SO2 by Vinmetrica is a burette. And it's very important to make sure the tip of the burette, and I'll show you that on the screen in a moment, is free of bubbles, and that you're also recording the volumes at the bottom of the meniscus at eye level. So you see the picture there. It's really easy to kind of just look at it, take a glance from wherever you are, but it's really important to get down eye level and make sure you're reading that line correctly, where that volume is. So finally, whenever you're doing laboratory work, you need somewhere to record your data. So thinking ahead and preparing a table so you can record your measurement information and then take that to a spreadsheet or something like that to do your calculations. So specifically for this one, we're going to be recording an initial volume on our burette, or VI, a final volume, VF, which we use to calculate a total volume. And then we're also going to need how much sample that we use, so how much wine that we use. And those numbers will all go into an equation, which I'll discuss at the end here after I do the demonstration. And we'll be using those to calculate how much free and total SO2 we have. So lastly, before we do the demo, some waste management procedures. So whenever you're working with chemicals, it's really important to understand what those chemicals are and the hazards that may occur when working with them. So consulting your safety data sheets, or SDS, along with local guidelines to make sure that you're handling that waste properly. Particularly with potassium metabisulfite, or KMBS, that sulfite salt that's often added to add SO2 to the wines is a respiratory irritant. So if you're breathing that in, it's going to make you sneeze and cough, and not good. And then the Vinmetrica reagents, the reactant specifically, if you look at that SDS, it mentions fertility danger, drowsiness and dizziness, and then it's also toxic to freshwater fish. So hopefully you're not ingesting any of these chemicals, but also you want to be cognizant of where you put them when you're finished with them. So dumping them down a drain, in which will eventually end up either in the public water system for cleanup or into a river or something like that. We want to make sure we're containing those things. And then additionally, we're going to be working with acids and bases. So those are corrosive. So again, wearing gloves, making sure that you're not touching your face or anything like that after touching these chemicals, because that can be really damaging to your eyes and other soft tissues, even your hands and skin, of course. But just make sure that you're keeping those contained. Now I'm going to turn off the camera here, and we're going to move over to the demonstration. We're measuring free and total SO2 using Vinmetrica. So that's this little device here. Comes with a probe. And there are a couple different models. So you'll notice that this one says SC300 at the bottom. And you've got a couple different options over here for measuring SO2, pH, TA, which is titratable acidity, and then a calibration mode as well. So they also have one that's an SC100, which only measures the SO2. So depending on whether or not you have a separate pH meter, consider, making sure you choose the right model for your needs. If you do have the SC300, you'll have a separate probe for measuring pH. So in order to do pH or TA, you would actually connect a different probe. And we talk a little bit more about those types of probes in the other workshops where we're measuring pH and titratable acidity. Okay. Additionally, you get Vinmetrica reagents from from them. So the SO2 titrant, because these are proprietary reagents, there's limited information about what's actually in there. But again, those SDS sheets will tell you the hazards associated with them. So we have three different reagents that we can get from them directly. The SO2 titrant, or the blue dot, which goes in my burette, and I'll show you that in a moment. We have the SO2 reactant, which is the yellow dot, and that's something that we add to our acidified wine sample. And then the SO2 acid solution, or the red dot, which is what we use to acidify the wine, to shift all of the free SO2, the sulfite form, over to molecular, so that it can react with the reactant. And then additionally, we're going to need some NaOH. Vinmetrica, I have it labeled as Vinmetrica NaOH, but it's 1.0 normal, which is a little bit different than the strengths that we've used for other measurements. But for this one specifically, the equations and everything, we want to use 1.0 normal sodium hydroxide. And then lastly, I have my wine sample as well, right there. Okay. So one consideration here when we're talking about our wine, make sure that you're set up and ready to go before you have your wine sample open too early. Because as I've mentioned, SO2 is volatile, which means it escapes into the air, and you can actually lose some of the free SO2 that you have in your sample. Thus, you would be underestimating the amount that you actually have in your wine in the tank or wherever you're getting your sample from. So I'm going to start here by filling up my burette with the titrant, which is the blue dot, and I have some in a little tube just to be handy. I'm using a transfer pipette to transfer my liquid over. And I'm using a much smaller burette, so I need to be careful about how fast I fill it to avoid bubbles getting in there. So I don't have a funnel today because it's such a narrow opening, and I'm using smaller volume. Might need a little bit of tapping here. Thanks for the assist there, Dr. Waterlow. So now I have my burette filled with the SO2 titrant. I'm going to wait until I get all of my other samples set up to record that initial volume. So I'm going to actually start my reaction for measuring total SO2. So I'm going to take, that takes 10 minutes to incubate. So I'm going to get that going, and then we can measure the free SO2. So I'm going to start by taking 25 milliliters of our wine sample. So if you have a burette pump, pipette pump like this handy and a pipette, go ahead and attach that. Some of these pipettes have two types of measurements. They go both directions. So at the top you have a 0 on one side, but if you turn it around, then it's a 10. Let's see if we can see that a little bit better. Go 0, 10, and 0. And you can end up filling it up too high. So just make sure you're looking at the right line. But I need 25 milliliters of wine sample. So I'm going to take this. I'm going to dial the wheel here, and the top of the pump goes up as the wine gets drawn up the pipette. And I can take it past that line a little bit, and then look at eye level. That's going to be 10 milliliters. Then I hit my little button, and the wine is discharged. Okay. Do that again. And that's 20. Make sure you depress the pump between each section. And I'm going to go up to the 5 mark. Then you'll notice that I'm discharging the wine kind of at an angle along the side of my beaker here. And that's just to try to limit oxygen integration and loss of SO2 as I process the sample. So, and then additionally, got a little drop of wine left in my pipette. That's built into the precision of the pipette, so don't do anything to try to get it out. We're just gonna set that down for later use. So now I've got my 25 milliliters of wine in a beaker. I can add a little stir bar here. And then 10 milliliters of my 1.0 normal sodium hydroxide, NaOH. New pipette. I don't want to contaminate any of my reagents with other chemicals or sample. And I've got 10 milliliters. Set my sodium hydroxide pipette over there, out of the way. And you'll notice color of the wine changed a bit. You can see it's kind of a green, much darker color than before where it was more red. And that's because the anthocyanin pigments shift to a more blue-green color under basic conditions. All right, so now I'm going to set that on my stir plate, give it a little stir here, and start a timer for 10 minutes. So that beaker right now has the 25 milliliters of sample and 10 milliliters of NaOH. And we're just going to set that aside and let it sit for 10 minutes. In the meantime, I can prepare my sample for measuring the free SO2. So again, I'm going to need 25 milliliters of wine. So I've got my first pipette back here. And my wine sample. So because SO2 is so volatile and reactive with oxygen, it's important to work with these samples fairly quickly. You want to make sure that you're set up, everything's in place before you get started. So that's 10 milliliters. $20. 25. So you can do this with different volumes of wine, but you have to make sure to keep track of what you're using so that the calculations will work out and be correct. Okay, now I have another 25 milliliters of wine in a small beaker. I can add a little stir bar here. And then I'm going to add first 2 milliliters of the acid. So that's the red dot bottle. 7.3% hydrochloric acid. And we just need 2 milliliters. So make sure you're looking at the right side. And 2 milliliters. Put that in my wine sample. And then take a new pipette. And do 2 milliliters of my reactant solution, which is the yellow dot. This one here. Okay. Okay, so in my beaker, I have 25 milliliters of wine, 2 milliliters of the SO2 acid solution, and 2 milliliters of SO2 reactant solution. In my burette, I have the SO2 titrant solution, the blue dot. So that is ready to go. Got my beaker on my stir plate. I start the stirring process, and then I can lower my SO2 electrode. I'm going to give it a quick rinse here with deionized water, just to make sure all the dust is off of it, or if there's any residue from the last time we used it. Giving that a quick rinse. And then I lower that into the beaker, making sure that I'm not hitting the tip of the electrode with the stir bar. Okay. So now I have my Vinmetrica unit turned on. It's displaying a value of 6.1. It should be definitely below 20, but usually when you just start, it's about 2. So that's still going down a little bit here as it sits. And then before I get started, I'm going to want to record my initial volume on my burette, again, at eye level. So seeing where the little curve of the liquid, that center of it at the bottom, I'm going to record that volume. And for this burette, I have 0.60. Make sure we write that down somewhere. And then we can start adding, just drop by drop, the titrant to the wine solution. And our endpoint, the time when we're going to stop, is when the Vinmetrica unit beeps for 15 seconds straight, or a count of 20 beeps. So it's a little bit hard to do constantly, but we'll see here, just adding drop by drop, waiting for the beeping to start. And then we'll turn the tap on the burette off, stop the flow of titrant, and start counting the beeps. And it might take several iterations, because if it only hits 10 beeps, we add another drop and start our count over. So we're looking for 20 consecutive beeps. Pull that back. 20. So I have 20 beeps. I'm going to go ahead and record my ending volume on my burette, which is 2.63. And then I can remove my probe from the wine solution. Otherwise, it keeps beeping at me. Not sure if the microphone is picking that up, but give our probe a rinse here. Dry it off. And then we would be ready for the next sample. So as long as we have those 2 numbers reported, the initial and final volume on the burette, that's all we need. and that sample is done. So that, again, that was to measure the free SO2. I'm going to go ahead and set that aside. And we're still waiting a couple minutes on the timer to measure total SO2. But while we do that, we can discuss a couple other points of error here. So making sure you have individual pipettes is really important for your different reagents, because if you contaminate them, they're no longer pure. You're not going to get the same reaction happening, and your values will be off when measuring SO2. So making sure you keep your reagents clean and uncontaminated, as well as fresh. So if they've been open for more than a couple of years, even a year, should have an expiration date on them. You'll want to make sure to get new reagents. You can order those directly from the Vinmetrica site. I sort of alluded to it once before when I mentioned the different modes on this unit, but make sure you're using the correct probe. So this blue SO2 electrode, it has a sticker that says SO2 electrode on it. That's the one for measuring SO2. The other one, which will have a storage solution vial at the end, will be for the pH. So making sure you're using two different probes for different measurements, and that they're connected to the correct port. So they have different connections on them, and make sure you're using the correct one. So, okay. Additionally, checking for bubbles in your burette. So at the, let me see if I can bring this a little bit closer here. The tip of the burette will sometimes capture bubbles. So making sure that you're looking for those, and you just drain out a little bit of the titrant before you get started and record your volumes. That'll ensure accuracy. And then when you're reading those volumes, again, just make sure you're at eye level, so that you get the best accurate measurement possible. And also being familiar with the precision or the graduation, so what each line means on your burette, because I mentioned that when we did titratable acidity, we used a 50 milliliter burette. So between each line is a different volume than on my 10 milliliter burette. So making sure you're looking at that and recording the values correctly there as well. And the last thing is to make sure that you're stirring during the titration. So if you don't have the fancy stir plate with the magnetic stir bar, got to make sure you're moving it with your hand, because as you add titrant, you'll want to make sure you're mixing that into the solution as well as possible, so you're getting an even reaction throughout. Okay, so our timer went off. I'm going to go back to my sample that was incubating with the 25 milliliters of wine and 10 milliliters of 1.0 normal sodium hydroxide. To that, I'm going to add, this time, 8 milliliters of the SO2 acid solution. So I have my acid solution, I have my pipette that I set aside specifically for that reagent. This is a 5 milliliter pipette, so I'm going to go ahead and add 5 milliliters, and then go back and add 3 more. And now we can see we've got back to a red color since we've acidified the wine now. Now we're shifting everything back. So the sodium hydroxide helps to break any of the bonds from the bound SO2, free it up, and then we're acidifying it to kick it over to the molecular SO2 stage, which is what we're going to be reacting with. So added 8 milliliters of the SO2 acid solution. And we're going to use the same volume as before, only 2 milliliters of the SO2 reactant solution. Then as soon as we add that, we'll want to work as quickly as possible and do the titration exactly as before. Put the stir plate there. Already rinsed my probe from before, so lower that in there. And then record the starting volume again. Always check your starting volume. Never assume that it's the same as when you stopped from the last time, because if something dripped or you needed to refill it, make sure you record that starting volume again. So here we're at 2.80, and then I can start my titration. Same as before, I'm going to go a little bit, just drop by drop again. But because I'm measuring total SO2 this time instead of just free, remember total SO2 is free plus bound SO2. My incubation freed up my bound SO2 to free. I should expect to use more titrant, and this will take a little bit longer to get to those 20 beeps than it did for measuring free SO2. As soon as you start hearing beeps, turn that tap on the burette off and start counting beeps. You hit 20, you're good to go. Record the final volume. If you don't, add another drop and then start your counting over again. Another note about the beeping. The way that this little unit, handheld unit works, there's a set point in there so that when the readout hits 50, the red stop light will turn on, and that's when the beeping starts. So those values don't have a direct meaning or correlation to your SO2 content. It's just with the voltage that you're measuring and that reaction between the sulfur and the iodine. So you might get a really high value, but it'll decrease as it continues to beep. But you're looking for 20 consecutive beeps before you call it the endpoint. Still waiting on those first beeps here. Got good stirring going on. My probe is completely submerged in my sample. $15, $16, $17, $18, $19, $20. So I heard 20 consecutive beeps. So I'm going to go ahead and record that final volume on my burette. 6.75. One last note before I leave my stir plate behind here. When you have your stirring going, make sure it's not creating too much of a vortex and pulling a bunch of air into the wine, because again, SO2 reacts with oxygen, and that's what we're trying to measure. So we don't want to have inaccurate results by adding additional oxygen to the wine. Go ahead and give my electrode a rinse and a good dry using my soft lint-free cloth or Kim wipes here. Okay, so I have my electrode rinsed off and dried. So that can be set aside for storage. Again, this solution or this electrode doesn't have a storage solution like the pH meter would. So that one is good to go. We're going to set that one aside. For the burette, make sure you turn off your stir plate too. But for the burette, I'm going to take my tube that I've got for my SO2 titrant and just drain the remaining titrant into that tube. And then at the end, I can put some DI water through my burette and give it a good rinse. So it's nice to have one of these little fancy bottles, but again, just using a transfer pipette to squirt some water down in the burette after you've drained out your reagent. The reagent you can either save for another use if you're going to go again tomorrow or something, or capture it in a waste container and dispose of it. And now that I have my initial and final volumes on my burette recorded, I can set that sample aside as well, and that's all we need. Just going to set something under my burette just in case it drips. But that's how we're measuring free and total SO2 by Vinmetrica. Now we're going to move back to the slides and look at calculations. So now that we've measured our free and total SO2 by Vinmetrica, we need to use the values that we recorded in the data table to actually figure out what we have. So this equation, it gives us a value for ppm or parts per million of free SO2 or total, depending on which volume you put into the equation. But the 64 correlates to the milligrams of SO2 per millimole of SO2, and a little bit of chemistry, but it's based on molecular weight. And then the capital V is the volume of titrant. So that's why it was really important to record the initial volume and final volume on our burette, which we take final volume minus initial volume to get the volume used. So that's the value we're going to put in. For my free SO2 measurement, we started at 0.6 milliliters, and then we finished at 2.63 milliliters for VF minus VI equal to 2.03 milliliters. So that's what I'm going to put into my equation here. The normality, or N, is the normality of the titrant. So again, that's the blue dot solution. And if you purchase it as prepared from Vinmetrica, that number is 0.0156. It's not the normality of your NaOH. So just make sure you keep that straight. Times 1,000 gives us a conversion from milliliters to liters. And then we take that divided by 2, which is a milliequivalent conversion for the SO2, and S, which is the sample volume of wine, or must if you're measuring juice or something, in milliliters. So for us, it was 25 milliliters. And that way, at the bottom, if we can simplify that equation, if we use that 25 milliliters and that prepared titrant, it just simplifies to 20 times V, or 20 times that volume of titrant that we used. So for our free SO2 measurement, 20 times 2.03, which is 40.6 ppm, parts per million of free SO2. So if we do the same thing for our total SO2 measurement, our initial burette reading was 2.80 milliliters. Our final volume was 6.75 milliliters for V of, or volume used of 3.95 milliliters times 20 gives us 79 ppm, or milligrams per liter, parts per million. Again, those units are equivalent, and that's our total SO2. So it's the same equation, same titration. There's just a little bit of difference in how you prepare your sample using the sodium hydroxide to free up the bound SO2, and then you measure the free. From there, so now that we've checked the level of free SO2 in our wine, again, we're going to use our free SO2 measurements to tell us about our winemaking decisions and what we need to add to the wine at different stages. In the next workshop, if you look at the recording for the SO2 by aeration oxidation, we talk a little bit more about when to add SO2 at those different stages of winemaking. So I'm going to save that discussion for that time. But when we're just looking at measuring free SO2, and then we want to know how much we need to add to have adequate protection, we need to check the level of free SO2. So that's what we did. We have 40.6 ppm of free SO2. We also need to know our pH. So remember that forms of SO2, seen here at the top of the table again, are dictated by the pH of the wine. So it's really important to know what pH you have before you calculate to know your addition. Additionally, you'll want to know what the intended purpose and the time of application. So what type of wine that you have will kind of dictate the amount of free SO2 that you're targeting. So as an example, a dry wine, so no sugar, we still have a few different things that SO2 can bind to. If we want to target 0.8 ppm of molecular SO2, this table tells us how much free SO2 we need to have. So previously I measured the pH of this wine and it was 3.7. So we go down to our table and we look at pH 3.7. We go over to the last column. For free SO2, we'll need 63 parts per million of free SO2 to obtain 0.8 ppm molecular SO2. And that's again for adequate protection for both oxidation and microbial stability. So we have how much we need to add, right? We know our pH, we know how much we're targeting. Our pH is 3.7. We want 0.8 parts per million molecular SO2. So we're going to add 63 ppm of free SO2. But remember the first step, we checked our free SO2 that we already had in our wine, and that was 40.6 ppm. So the addition that we're going to make is going to be less than 63. So 63 minus 40.6, which is 22.4 of free SO2 that we need to add. So our target is 63. We had 40.6. We need to add 22.4. So how do we do that? I mentioned previously that one of the most common ways of adding SO2 to a wine is by adding a sulfite salt. So something like potassium metabisulfite, or KMBS for short, which is 57.6% SO2. You can see the molecular structure over there on that pile of white powder. You have some potassium in there, so that takes up some of the weight, the percentage. So of SO2, we have 57.6%. And then this equation here gives us, we're going to just put in some numbers here for the sake of an example. So for our measurement, we wanted to add 22.4 ppm of addition. So that's how much we want to add of SO2. And then let's say we have a 100-gallon batch of wine. So we can put in 22.4 times 3.785, which is a conversion from gallons to liters, because we want to make sure that all of our units cancel out and the metric system works better for that. So we're going to convert our 100 gallons of wines to liters with that 3.785 factor times 100 gallons. And then we'll divide that by 1,000, which converts us from milligrams to grams, or milligram per liter to gram per liter. And then times 0.576, which accounts for that 57.6 of SO2 in KMBS. So if we do that math, we get 14.7 grams of KMBS. So we could just add that amount of KMBS to our wine. Usually you'd want to solubilize it in some wine or water before you put it into the solution. However, remember, some of the SO2 that you add will bind to other components of your wine. So 30 to 50% is needed to reach your free SO2 target, because some of it will bind right away. So if we're targeting that 63 ppm of free SO2, and we need to add 14.7 grams of KMBS to meet that minimum. And then if we consider 50% additional, we need to add an additional 7.35 grams for a total of 22.05 grams of KMBS that we want to add to our 100 gallons of wine that has 40.6 ppm of free SO2 to meet our target of 63. Okay, hopefully that was clear. So some might be wondering why there's such a range in that binding capacity. Is that 30 to 50%? Which one do I target? And that can just depend on, again, your wine style and sort of your overall goal of protection. So if you're targeting 0.8 ppm of molecular SO2, you might choose a different number like 0.6 or 0.5 for a dry red versus a dry white, because red wines have compounds that have antioxidant properties, so they have some innate protection. However, keeping in mind that in Iowa and the Midwest, we grow hybrid varieties which have low tannin values. So we'd want to almost treat that as like a white wine addition. So having that 0.8 ppm of molecular SO2 target in mind, and then erring on the side of caution to just use that 50% extra for the binding relationship. So that's why we did the math that way. But again, depending on your wine and your particular situation, keeping in mind that you've got a sensory threshold to keep in mind and legal limits as well for your total SO2. So just to start wrapping up here, we do have some fact sheets available at the ISU Extension Store. Just Google Iowa State Extension Store. It should come up right away. And then you can search on there for wine fact sheets or specifically on sulfur dioxide methods or methods for analyzing sulfur dioxide, that FS62 number. But if you just look for wine fact sheets, you'll have a whole bunch of different ones that will come up for titratable acidity, pH, total soluble solids, and then the SO2 ones as well. So those are free and available online, published through Iowa State Extension. So with that, I'd like to thank Dr. Waterlow for the opportunity to work on this workshop, and then Iowa State University Extension and Outreach for their support and funding, because without that, we wouldn't be able to offer these free workshops to the Iowa and wider Midwest industry. And then stay tuned for the other workshops in the series, notably measuring SO2 by aeration oxidation. That'll give you another look at SO2 measurements by a different method, along with another look at the theory. So thank you, everybody. Have a great rest of your day. Bye.